Welcome back to our live training session. In this training module, we're going to complete our base map creation process that we started off in the last tutorial. So the last training module, we were focusing on setting up the inputs, the outputs, as well as any of our configuration settings. This training module, we're going to complete the base map creation process, setting up our two-dimensional and three-dimensional tables so that they're best representative of the engine and the configuration of parts that we're working with here. So let's first jump in. We're going to go into the FT Manager software that's open on my laptop screen, and we're going to move in here to our area called Fuel Tables. We're going to work our way from the top all the way down through each individual table and make sure that it has reasonable values or it's set up properly for our engine. So some of the tables we don't need to necessarily rescale, but we want to make sure that the values make sense that are in the tables. Other tables, such as our fuel table here, we need to completely rescale this in terms of our breakpoints. These breakpoints aren't going to represent the engine that we're dealing with, and we'll explain that process and what we're looking at here in just a minute. So this is going to be completing everything. We're going to go through everything here from fuel tables, ignition tables, other functions, make sure we have things in here that make sense. Going down here a little bit further, we went through the engine settings already, and we'll just quickly go through sensors and calibration. I think we've covered everything there in the last training module. But again, this is going through that generic file that we started off with from the base map creator with the Fuel Tech, just making sure that everything's in order and that we're going to have the best success of getting our engine to fire up and run when it comes time in the next training module. So building a base map is always about trying to incorporate all of the variables that we can account for without the engine running. And then we load the file to the Fuel Tech, we crank over the engine, and we start to deal with calibrating and tuning from that point. All right, so let's jump in here and take a look at the very first thing. That's going to be our fuel table. We can look under our fuel tables. That's our map RPM fuel table primary. This is where we command the injector pulse width, the pulse to the injector, to put the fuel into the engine. Now, Fuel Tech is going to be an injection time pulse-based system. See, taking a look at the table values here, this is going to be the pulse width that we're going to command to the fuel injectors. I can tell you right now, looking at the pulse width here in vacuum, 5.5, 6 millisecond. This is in millisecond time, entirely too high. We're probably going to be running about 1.5 to 2 millisecond, if I had to guess, for the engine to fire up and run in vacuum at idle. Now, once we go above idle, that pulse width is going to increase, the fuel flow is going to increase, but generally speaking, for most any engine, if we have upgraded injectors, we're going to be anywhere between about 1.5 to 2.5 millisecond, also depending on the fuel. So if you're on ethanol or methanol fuels, the pulse width will be higher, but the values in here are way, way too high, which is going to throw everything off when we go to fire off the engine. It'll crank, fire, and run. It'll be extremely rich to the point where it could actually foul at the spark plug. So we want to go in and change the actual table values. But more importantly, before we do that, we need to go in and take a look at the table based on the breakpoint axes here. We can see the table scaled up to about 29 PSI, which is about 3 bar of boost. I'm naturally aspirated. I'm not going to see boost with my engine. So I don't want to waste essentially half of my table resolution on boost, what I'll never actually hit. I want to go and rescale the table so it's characterizing my engine vacuum here that we can find down below. So we can simplify and actually shrink down some of our table here. We also need to factor in our engine speed breakpoints at the top. We can see they're going to be based on engine RPM. Now, the reason why we want to go and scale down or scale up or down our breakpoints is so that it better represents the power band of our engine. For example, I'm going to rev my engine to about 8,500. This table only goes to 8,000. That's going to create a problem for a fueling delivery because the Fuel Tech's going to just go and take a look at, let's say I was revving it to 85, 9,000. It'll take a look at what the last column value is going to be at that map pressure I'm running my engine at, and that's what it's going to run for the pulse width or fuel flow to the engine. It's not ideal. We have no real control then over what fueling we're putting into the engine. We want to be specific with our breakpoints and setting up and scaling our table, so let's go ahead and do that right now. I'm going to click on any of the axes, right click, go to edit axes. The first thing let's consider are column axes. That's going to be our engine speed. Let's rescale this so that it makes sense. So if we go in here, we can use a generate columns, and this is going to allow us to do a rapid generation of our actual breakpoints. Let's do that right now. So the first value we'll put at 0 RPM. The last value, I'm going to put at 9,000 RPM. We'll move in 500 RPM increments. What this is telling me here is that I have 19 total breakpoint sites that are going to be allotted up at the top here to go between 0 to 9,000 in 500 RPM increments. We have a total of 32 available sites. So the table could actually be bigger and have more resolution if we want it. For right now, I'm going to keep it simple and just move in 500 RPM breakpoints. This should be sufficient for pretty much any engine you're tuning. Let's click OK. Then if we go to row axes, this is going to be factoring in our map pressure reading from our map sensor. For negative 14.5 is full engine vacuum. We absolutely want to have a column placed there, or not a column, a row in this case, placed at that breakpoint. And then the maximum we'll probably go to is something like maybe 1 or 2 psi. There is a chance that I could get a ram air effect with the intake setup that I have on the vehicle here, and then I could build some positive manifold pressure, technically, if I'm going at very high speeds. I don't anticipate that happening, but it allows me to factor that into my breakpoint scaling for my naturally aspirated engine. Now, if you're forced induction, you'll have to scale this a little bit higher than you anticipate for the highest boost you want to run for the engine. So for example, if you plan on running 30 pounds of boost on the engine, scale your table up to something like 35, 36 psi. That way, if the boost goes up a little bit higher, it can account for that in your breakpoint scaling. So just some things to keep in mind. Let me go in here to the generate option, and the first value we'll place is negative 14.5. The last value, let's do 2 psi. And we're going to go in the incremental values at something like, in this case, let's do 1 psi. And give ourselves a lot of resolution. Let's click OK. So now what we're left with is a table, as we can see here, that has a ton of resolution in the scale for vacuum, and it's scaling the table all the way out to 9,000 RPM. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.